Geometric minds. We have a small problem here in shaded area we are going to solve today, and the author made two semicircles, one inside each other, and we have a shaded area, the blue one here, to calculate. They have given us the value of AD. They said AD was 10, and then AF is 6, and EC is 12, and they want us to find the blue area, the blue shaded area here. And to find this blue shaded area, we have two ways. The main part is to find the radii, the radius of this small semicircle and the radius of the big semicircle. Once we find these two, it will be easy to find the area. We can just head to GeoGebra and do the drawing, or go the long way, which we are going to use today, and calculate each and every part. So I have added these parts here. So we are going to successively calculate A, calculate C, calculate the angle at B. We called it beta, and then the angle at G, we called it gamma. Once we have these, we just calculate the area of DBE, the triangle, and then we calculate the sector, the blue gradient sector, and we make the subtraction. We subtract the sector, the segment, I mean, from the area of the triangle DBE. So a lot of things to do here. Let's start. I'm just going to go and start calculating part by part. Small r, big R first. Once we have these two, we are going to continue and tackle small a. And once we have a, we already have alpha. We are going to calculate c. And once we calculate c, we can calculate b, in the big triangle ABE. And once we calculate angle at B, we called beta. We can calculate the sine of that, and then we know the area of triangle DBE will be just the product of the two sides AC and the sine beta. So here is what we found. We found that AC is equal to 6 plus 2R plus 12 is equal to 2R also, two big R's. That means that big R is equal to 9 plus R. And 6 plus R squared in triangle ADG. 6 plus R squared is R squared plus 10 squared. AD squared, I mean, is 36 plus 12 plus R squared is equal to R squared plus 100. That means 12R is equal to 100 minus 36. 12R is equal to 64. That means we can find the R. The R will be simply simplified here. 16 over 12, 64 divided by 12, simplified by 4. We get 16 over 3. So we have small r, correct? So once we have the small r, we are going to calculate and continue to calculate the big R. We know that big R was just simply 9 plus small r. So the big radius, okay? So we have that, and we are going to continue to calculate AC, which is equal to 2R. That means R is equal to 9 plus small r, as we found on top there. It's equal to 9 plus 16 over 3, the same denominator here, and we get actually 43 over 3 altogether once we finish the calculation. All right, so we have small r and we have big R. We go back to our drawing and we try to find small a. How to find a here? We have to combine. We know that triangle ADG is really similar to triangle ABC. It's a cosine alpha then is equal to AD over AC is also equal to AB over AC. So not AD over AC, I mean AC over AG. AD over AG here, you know, is equal to 10 over 6 plus R is equal to also 10 plus A over 2R. 2R is simply 86 over 3. So we just go and plug in these values. So the first one is AD over AG, 6 plus 16 over 3 is equal to 10 plus A over 86 over 3. So let's go ahead and do the calculation here to pull A. So we just first put everything together here. 6 times 3 is 18. 18 plus 16 is 34. So put 18 over 16 here. Okay. And then we put the 3 on top there actually now. All right. So, and then this is equal to the 3 from the bottom here. Factor 10 plus A over 86. All right. We cross multiply these now. We can say that cosine alpha is equal to 30 over 34, which is also equal to, if we simplify this by 2, 15 over 17. Which is now is equal to 30 plus 3A over 86. Now comes our cross multiplication, which is 15 times 86 is equal to 17 times 30 plus 17 times 3A. All right. Oh, we are getting there. Okay. So once we have A, we are now going to look at the big picture and look at triangle ABE. And if we have triangle ABE, we have already 3 elements we know. So we have A is equal here now to 780 over 51. All right. So once we have that, we are going to calculate the side C. All right. Okay. We know that we already have angle alpha. We already have angle A, side AB. We also already have side AE. All right. So we are going to try to calculate A. We are going to calculate C, I mean, using the regular formula, the fundamental formula of the cosines. So it will be very simple here, getting C. So in triangle ABE, I was saying, go ahead. AB is equal to 10 plus A is equal to 10 plus 750 over 51, and we just multiply everything. We get 1290 over 51, and we will simplify this one later. If we divide by 3, we nearly get 43 over 17. So that will be the value of AB we are going to use to calculate C. Okay, and also we just put into value AE. So AE is equal to AF plus double R. To R is equal to the 6 plus 2 times 16 over 3. All right, so we have that. We have 18 plus 32 over 3, so 50 over 3. All right, let's simplify this 1290 over 51, which is huge if we square this up. So we just simplify it by 3 for 30 over 17. So very good. So now we are ready to tackle C. So to tackle C is very simple. We just the fundamental formula of the cosines, and we have in triangle ABE. We say that it is equal to cosine. We say it's a C squared. It's a C we want to find. C squared is equal to AB squared plus AC squared plus AE squared minus 2 times AB times AE times cosine alpha. All right. So far so good. So we are in good shape to find the value of C here because we have everything we need. So just plug in these values. So we say C squared is equal to 50 over 3 squared plus 43 over 17 squared minus 2 times 50 over 3 times 43 over 17 times 15 over 17, and all together we pull C. So we take the calculator and we calculate C. We say C is equal to 130. It is 13.17670,401. Now we are going to find our angle beta. Looking at the small picture ADG, you know sine alpha is equal to 6 over 6 plus R. All right, which is equal to 16 over 3 times 6 plus 16 over 3. So sine alpha is 8 over 17. We will need this, okay, later. You'll thank me for that. And now, still looking at the triangle ADG, we know that angle beta exterior to the triangle is equal to 90 plus alpha. These are the two angles plus alpha. All right. But okay, not gamma yet. So let's calculate beta first. Sorry, we are going to still use the triangle ABE. So we know that sine alpha over C is equal to sine beta over AE. So sine beta is equal to AE times sine alpha over C. Okay. All right. So we are not in gamma yet. So sine beta, we can just plug in these values. We can find that is equal to AE, or AE is 50 over 3 times sine alpha. Sine alpha is 8 over 17 times 1 over C times 1 over C. See, we found C is 13.176, and all values you would see there. Okay, so once we have that, we are going to continue. We are going to continue to calculate. Okay, we found that sine beta is 0.59 522 7 5508. Okay, so we have found that. We have found that sine beta. So now once we have found this sine beta, we have to calculate the area of triangle DBE. has become simple now. It is 1/2 of AC times sine beta. So we just plug in these values again. It's going to be too fast now. It's we know what A was. It was 780 over 51 times C. C, we just found C. C was 13.17670,401. So we have that, and then of course this writing may not have included the sine beta. We just found it up there. Sine beta should be times 0.595,227,5508. So finally we get the area is equal 59.976. There you go, 976,93195. Thank you. So we have that, and once we have that value, we have the triangle BDE. So all we need to do is to tackle to find the segment, the blue segment there. So once we have this area of triangle DBE, we just emphasizing it here, 59.976,93195. We have to find the angle gamma. So the angle gamma, to find angle gamma here, we have to look at small triangle ADG. ADG, we know that a gamma is exterior to the triangle. So it's the sum of the interior angles. You know, angle at D here is 90 degrees because, you know, it's the tangent to the semicircle. And then we just say that angle gamma here then is equal to 90 degrees plus alpha. All right, we have the value of gamma because we can find alpha from sine alpha. So we know that sine alpha or cos alpha, whatever we use, is equal to 8 over 17. So that means we can find alpha, and then we plug in here, then gamma is equal to 90 plus whatever angle we find is gamma is equal to 118.072 48696. Okay, all right, and once we have gamma, you can calculate the segment here. The segment must be deducted from the area of the triangle we found earlier, DB. So we just get down here and find segment is equal to, you know that the segment is equal to the area of the sector, pi r squared times the angle times 118.074869 over 360 minus 1/2 minus area of the triangle 1/2 of the RR sine gamma. Okay, so we plug in all these values, we find that the segment has a value of 16.75961626. Very good. So now we have the two areas we wanted to subtract, and it becomes a short affair. Now we are at the end of this problem. So we killed the problem, and we found that the blue shaded area requested by the author at the beginning of this problem is just simply the area of DBE minus the area of the segment. That means it is our 59.976939115 minus our 16.75961626. And finally, we find a shaded area, which is just valued at 43 0.2173156 units squared. Thank you for watching, and it was a long one, but we had to use analytic geometry to tackle this problem here, while if we used GeoGebra, I could have just taken 3 to 4 minutes. Thank you.